Next. Have you seen the video about this ancient Greek symbols? Did I show you the video?
I don't think so.
No, we haven't, because we got a very long gap. So I want to cover that gap in this session itself. So ancient symbols by alchemist and John Dalton. So how we got alphabets? How we got alphabets? When we got alphabets, the A means single A, B means single B. It's not very complicated. That's why we'll remember all the alphabets which we learn in our early classes. Yes. At the same day, so to remember all this 118 element in like writing the chemical, like in writing like spelling and all, it's very difficult. In that point of view, many scientists or all chemists means all these are scientists only. They worked in this like research work in chemistry, so they called as alchemists. Okay, different alchemists has given different views about the symbols. So for example, so they have taken the symbols based upon three principles. One is what? One is fire, air, water, earth. So as we open our like graph paper, have you seen the graph paper anytime? Rectangular shaped graph paper? Yes or no?
Yes, ma'am.
You know the graph paper? If we divide from the center the graph paper into how many zones? 4 different zones. Like this, like plus mark, if we divide the graph into 4 different zones, so they have divided 4 different zones. One is like fire at the top, water down, air towards left, and earth towards right. So they placed all the 4 different zones. At that particular time, whichever atoms were found, they placed under these 4 categories only. These 4 categories only. Understood? Yes or no? So these 4 categories, on what basis they'll divide? So they have kept under fire, and if the elements were found, they are very much warm. If they are very much warm, then they placed under fire and air. So I'll show you the video. Again, I'm going to explain it. Okay, I'm just stopping or muting my audio so that it won't get any resound. Okay, meantime, just go through the symbols. Understood? Symbols by alchemist, symbols by John Dalton, how he has given. So alchemist has viewed only 4 different zones. So when they place the elements which were found at the time into these 4 different zones, it's very difficult. Why it's very difficult? There is no unique identity of individual elements. But these 118 elements are having different properties. All these 118 elements are having different properties. Based on the properties now they have arranged, leave about the arrangement of the elements, but they have not given the identity for the individual elements. Okay. So when we go for the identity of the individual elements, that means if I want to know about, like in the class, your roll numbers will be there. So whenever I call roll number 5, in the sense 5 is having its identity, so she got the roll number 5. So if I call 5, so when it comes under, all 5s will come, like 5, 15, 20, 25, all 5s will come? No, only roll number 5 will stand up and she'll come. Understood? So in that case, only that based upon the roll number, how the identity of the child is standard in the class, at the same, the identity of the element should be there. So they were failed by giving all how many elements were found. They have divided into only 4 different zones. But that means that sorting out the things is easy to learn. But to make the things like all the elements in 4 different zones, so that individual identity of the element was not mentioned clearly. So this drawback was established by John Dalton by giving pictorial presentations with pictures. So to remember all the pictorial presentations of the element, but here taking the drawback of all chemists is well and good. He has considered all the drawbacks of all chemists. It's very happy to learn. But what is the main drawback of John Dalton? To remember all the symbols, to draw the symbols with filling and everything, it takes much time and it is very difficult to memorize all the symbols. Understood? In that point of view, it's very difficult. So this is also John Dalton's also having a drawback, so that which was established by Baron John Jacob Berzelius. To make the things easy for the next coming generations, even now we are following his ideas, but different scientists working on that, but the main basic principle is mainly taken by Berzelius. Understood? The main idea were taken by Berzelius, by taking the Berzelius idea. Now, even now we are giving the names. So mainly the names of single letter, first letter, single letter, or by giving the prominence to the two letters, or the symbols can be taken by two letters, or we can take three letters also. We can see that in the periodic table, the three letter symbols also.
Ma'am, and also the Latin names.
Yes, Latin, I'm not saying the quantity of the symbols. Like one letter symbols will be there, two letter symbols will be there, or three letter symbols, not four. Understood what I mean to?
Yes. Yes, ma'am.
So Berzelius has given different views and different ideas. In what sense he has given the names. So other than the symbol means, it is completely different from the name. Understood or not? And even if we write the complex compounds, what are the complex compounds? C6H12O6.
Glucose for.
When we go with the complex compounds, to draw the symbols are very, 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 very difficult.
No, ma'am, to write them, it's very easy.
For drawing the symbols?
No, ma'am, writing.
Huh? Yes. Bhavya, you are saying something? Pardon? Bhavya? Are you texting?
Ma'am, when writing this, writing the compound, it is really easy.
So writing the compound, leave about writing the compound. At that time, they haven't given about the atomic number. That means 6 times carbons need to be drawn. 7, 11, 12 times hydrogens need to be drawn. And 6 times oxygen symbols. It's very difficult to draw. Writing is easy. But drawing the symbols got very difficult, and to remember all the shapes, very, very difficult.
Yes, ma'am. Yes, ma'am.
So next, Berzelius has given different views based upon the prominence to the first letter and prominence to the second letter, even with the Latin names. Okay. So modern view. In 1814, Baron John Jacob Berzelius suggested a simple system of representing elements with symbols. Okay. So how to represent the elements with symbols? So when I'm writing hydrogen by using the alphabets, the symbol is nothing but the first letter of the hydrogen. First letter of the symbols.
Yes, ma'am.
Understood? So mainly he considered the first letter of the symbol by writing the alphabet. Naming the compound like hydrogen, helium, lithium, hydrogen, H, capital H, carbon, C. Simple, no? Nitrogen, N, oxygen, O. By taking the first letter, prominence to the first letter. And he has given one more rule that, so if all the elements, most of the elements starting with the same first letter, then he gave the prominency to the second letter or the third letter.
Yes.
Second letter or the third letter. So by giving the prominency, so he has given the symbol by 2 letters. And how to represent it? First letter always should be the capital letter, and small letter should always, second letter should always be a small letter. Which chapter is
Yes,
this?
ma'am.
What chapter? Language of chemistry. I haven't seen that. I said no. What chapter is this, children? What happened, Bhavya? Are you all perfect in listening about the title of the lesson?
No. Yes, ma'am.
Okay. Your sister typed it. Okay. Okay. Say hi to her. I'm very much shocked that after listening to the concept, you are asking which lesson teacher. Okay, no problem. No problem. Let it be. Just concentrate to the class. Okay, symbols with the Latin names. So he has given the prominency to the first letter and prominency to the second letter, and the next one is prominency from the Latin names. So sodium is taken from the Latin name natrium. Sodium is taken from the Latin name natrium. Copper is taken from the Latin name cuprum. Gold is taken from the Latin name aurum, the symbol Au. So though they are taking from the Latin names, they also, he considered the first letter or the 2 letters or second letter or the importance to the third letter. Understood? Even now, Virgilius won't be living at present, but his ideas got living up by the upcoming scientists. These scientists have worked on the ideas and the thoughts given by proved statements given by Berzelius.
Okay, ma'am.
Understood? And one more few examples I can give. Not only it depends upon the first letter or prominency to the second letter or third letter or with the Latin names, they also given based upon the places from where these elements got found. Understood? So if the new element, man-made element got found in America, so it's called americium. Americium. And some, what I can say that the satellites names also. Okay, or even some, what we can say that planet names, based on the planet names also. Uranium, plutonium. Yes, uranium, plutonium, all these.
Ma'am, and even in scientists, ma'am, Einsteinium,
curium, Madam Curie. From the name Madam Curie, curium.
ma'am, and Mendelevium for Mendeleev. Ma'am, Mendelevium, Dimitri Mendeleev.
Mendelevium by Mendeleev.
Ma'am, and Lawrencium.
Laurentium. So all these are the different names. Though they have taken from the scientist place we got where the elements were found or any other thing or the Latinans were, but he considered 2 letters or 3 letters. And that 2 letters or 3 letters also from the name of the element. Yeah, I just give you, when I'll give you all these things, this PPT, I'll ask them to place this PPT. In that PPT, I just give you. No need to worry. Otherwise, I'll prepare one more slide in the next coming class and I'll place that slide for 2 minutes so that you can write.
Okay.
Okay?
Okay, ma'am.
So, any doubts?
Ma'am, you don't need to write when it's there in the periodic table, ma'am.
It's there in the periodic table, but we don't know in what prominency they have given, no? Yes? Until and unless we'll study about it, then only we can understand. Symbols for the prominency to the first letter. Have you seen? Hydrogen H, nitrogen N, oxygen O.
Yes.
And symbols for the prominency to the second letter, helium He, calcium Ca, beryllium Be. So how we are representing the elements? First letter always should be the capital letter and the small letter, and second letter should be the small letter. Don't write He, capital H.
I have a doubt.
Yes, Bhavya.
Ma'am, for boron, the symbol is B, right? Boron.
I did not write boron here. Beryllium B.
No, ma'am. I'm just asking for boron.
Yes, for boron B. Yes.
So, ma'am, can we put can we do write that in the chart of the what do you say? First letter is
Definitely. Why not? I have given only few examples. If you know how many you want to write, just note down. Very good. Very good.
Ma'am, like while reading the periodic table only, we can tell that there are scientist names.
And that also we know only few scientist names.
Ma'am, like borium and Rutherfordium.
Rutherfordium, yes. Rutherford, yes. Goldsteinum, Einsteinum, from Einstein. Okay, symbol based on the first letter followed by the next prominency. So that can be taken the prominency based upon the third letter importance or the fourth letter importance. Cadmium CD, chlorine Cl, platinum Pt. Prominency they have taken like importance, maybe they have taken the first letter or the second letter. Sometimes they also taken from the third or the fourth letters. CD, Cl, Pt. Next. So symbols based on the Latin names. C. Sodium from the Latin name natrium, Na. Bhavya, I think I have given the slide. Just check if you want. I just leave the slide for 2 minutes. Meantime,
okay.
I'll arrange for the video so that you can write, Bhavya.
Okay.
According
Okay,
to
ma'am. Thank you.
Very good. Very good. Okay. Am I there in the meet?
Yes, ma'am.
Something happened. So maybe my audio is working, no? I think video got off.
Yes, ma'am. Video got off. Audio.
Yes, ma'am.
Audio is there, no? Just go through it. Okay, I just on like a 1 minute time I'll take and I'll just on my video. Maybe like network. That's what I got a doubt that whether I'm there in the meet or not. Okay, symbols based on the Latin name sodium. It's taken from the Latin name natrium. Na. Potassium. It's taken from the kalium. K. Iron, ferrum, Fe. Copper, cuprum, Cu. Silver, argentum. Ag. Gold, aurum, Au. Lead, plumber, Pb. Mercury, hydrogen, Hg. Tin, stannum. Sn, antimony, tibium. Sb, tungsten, wolfram, W. So if you want to make a note about it, you can. Like 1 minute only, I'll leave the slide and I'll go with the next slide.
Ma'am, where is tungsten, ma'am?
What here?
Ma'am, tungsten, which is 74, ma'am. Atomic number.
Yes, leave about the atomic numbers. We'll learn about the atomic numbers.
No, ma'am, I couldn't see it for a minute and then I started reading and then I found it.
Yeah. Over. Shall I go to the next slide?
Ma'am, yes, ma'am. Now you can go.
Yes.